Welcome to Flutter Teacher. In this session, we will talk about the factory constructor. So before I start the video, let's understand the topics that I'm going to cover in this video. So we'll start from what the factory constructor is. Then I will explain the 10 different characteristics of factory constructor. And finally, I will talk about the use of factory constructor. Here, I will explain 4 different use of factory constructor along with the 4 different examples. So without wasting time, let's get started. Let's understand what the factory constructor is. Basically, the constructor written using the factory keyword is known as the factory constructor. All the constructors that we have seen so far in our videos are known as the generative constructor. Whereas when we write a constructor and we use the keyword given by the Dart called factory, then such a constructor is known as the factory constructor. Factory constructor is similar to the static method and it must return an instance using the return statement explicitly. Now, why I'm saying that it is very much similar to static method because it has no access to this reference and it cannot access the instance member, that is the instance data and the instance methods of the class. And it must return instance using the return statement. Look at this example. Here we have ABC, which is the default constructor. Then we have abc.demo, which is the name constructor. Both this ABC and abc.demo are the generative constructor. Generative in the sense that it actually initializes the object and return the instance which is initialized by the constructor itself. On the other hand, we have factory constructor. Factory constructors are not the generative constructor, means they cannot initialize the given object. In fact, they rely or they depends on the another constructor to initialize an object. That's the reason it has to return the instance explicitly by using the other constructor. It means there cannot be only factory constructor in the class. There has to be at least 2 constructors in the class. One is the generative and the another one is the factory constructor. And through the factory constructor, we must return the instance. Making a call to factory constructor is very much similar to the normal constructor. You can see inside the main, we have this ABC obj reference, then abc.test. So when we write this abc.test, it looks like a call to the normal constructor, that is called to the generative constructor. But it is actually a factory constructor which is relying on the default constructor. That's why inside this test.abc factory constructor, I'm returning the instance of this abc. So you can practically say that I'm calling this test.abc, which is a factory constructor, but actually the object initialization is done by the constructor, that is the default constructor abc. Now, you might have a big question in the mind that factory constructor can't work independently. It has to rely on some another constructor to initialization. Then why someone should use the factory constructor? Answer is there in this video. You just have to watch and have a patience until I explain the topic called use of factory constructor. Let's understand the characteristics of factory constructor. Factory constructor must return an instance. It might be the instance of same class or subclass using the return statement explicitly. Look at this example. Here we have a class called ABC that contains the default constructor and we have the abc.someName, which is the name constructor. Then we have the factory constructor called abc.callMe. So as we have written a factory keyword before this constructor, it is the factory constructor. That's the reason inside the body of this constructor, it's compulsory for us to return the instance. So in this case, I'm returning instance by using the default constructor. So if I delete this line, you can observe in my code, I will get error that it says that it's compulsory for me to return something, that is, it is returning the null. So this explains or this proves that in case of factory constructor, it's compulsory to return the instance by using the another constructor. Let's say if I delete factory keyword from here, then now it becomes a normal constructor, that is, it is the generative constructor, and for such a constructor, we cannot return something from here. Factory constructor can be named or unnamed, and it is invoked like the normal constructor. Just look at this example here. We have the constructor called ABC, which is basically the unnamed constructor, and this one, that is the abc.someName, it is the name constructor. And here we have the abc.callMe, it is actually the name constructor and it is the factory constructor. So we can see in case of line number 13, I'm calling the normal constructor, that is, I'm calling the default constructor. So if I want to call this factory constructor, then simply I can write abc.callMe, and that's that. So we can observe here the call to factory constructor is very much similar to the normal constructor, that is to the generative constructor. Now in this case, I have the factory constructor as the name constructor. I can change it to the unnamed, that is, I can make this one as like the default constructor. For this, first of all, I need to delete this constructor from here, and I can convert it to the say, default one, that is the unnamed one. Then I must return the instance by using this abc.subname. That's great, and let me format my code. Now let me explain a little bit here. So abc.subname, it is basically the name constructor, which is of course I'm using to return inside the factory constructor. And you can observe here, my factory constructor is not the named one, it is the unnamed one. That's the reason in line number 12, I need to change it to the different call, that is, I need to change it to the normal call. And now it gives me a feeling that I'm calling a default constructor, but it's not actually default constructor, it's the factory constructor with the no parameter, that is, it is actually the unnamed factory constructor. So hope it's clear what do you mean by the factory constructor can be named and the unnamed. Like the normal constructor, factory constructor can also accept the parameter. So it can be the named parameter, positional parameter, or even there can be a combination of named as well as the positional parameter. That's what we have seen in case of the normal constructors. Just observe here, we have the constructor called abc.callme, which is the factory constructor. And inside this constructor, we have two different parameters. Now these are the named parameter. That's the reason in line number 12, when I'm calling this constructor, I need to write abc.callme and the value 10 and 20. So 10 will go for the x and 20 will go for the y here. Now let me change this parameter from the positional to the named parameter. So I need to put them inside the curly brackets, and that's done. So as we have the name parameters here, so I need to change these parameters. That is, I need to change it to the call with the name parameter. So I need to write here, let's say x colon 12, and I need to write here y colon 20. So as we are in the world of non-nullable field, so as these are the non-nullable variable, so I need to write required here. So let me write here required, and let me copy this required from here, and I will paste it for the y as well. And that's done. Now you can observe here, this basically a factory constructor has the named parameter. So the value for x and I have the value for y. Even we can have a combination of them. So let me change it to the combination. So if I remove the bracket here, let me add the bracket here. Now in this case, what will happen? The x is basically the positional parameter and y is the named parameter. So as x is the positional parameter, I need to pass value for this one. So it's compulsory and it has to be the first parameter as we have seen in our previous videos. And y is the name parameter, and that's the reason I'm writing y colon 20, but it's giving the value to y. Factory constructor cannot access instance members of class. It means it cannot access the instance data, that is instance variables and the instance methods of the class. Just observe here, in case of class ABC, we have the variable x, and which is basically the instance variable. Here we have the default constructor, so it can be a default or it can be the name constructor. Basically it has to be the generative constructor. So inside the generative constructor, I can happily use this variable, that is the instance variable here. It's quite fine, but as this abc.callme is the factory constructor, I cannot use this instance variable. So if I look at the errors in my code, you can observe here it says that instance members cannot access from the factory constructor. Let me define some method here. Let's say I would like to have void. Let's say some method. Say some method. Now you can observe here, I can call this some method inside the constructor. So let me call it inside the generative constructor. Let's say some method. So that's going to work fine. But if I try to call it here, let's say let me call it here, then we'll observe here I will get another error because the sum method is actually the instance method and it cannot be called here. So it again says that in line number 16, instance member, that is the instance method, cannot be accessed inside the factory constructor. Factory constructor has no access to this reference. It means we cannot use this keyword inside the factory constructor, not to access the members of class, not even to call another constructor, and not even inside the initializer list. Let's understand this one with an example. Here we can see we have the instance variable x here. So inside a constructor, I can simply write this.x. So that's going to work fine here. But if I try to write here, let's say this.x is equals to 100, then I will get error here. Let me show you the error. In line number 10, that is inside the factory constructor, it says that invalid reference to this expression because we cannot use this inside the factory constructor. We know that that has given the syntax trigger inside the constructor to initialize the members. So let me use it here. So we need to delete this bracket, we need to add a semicolon, and simply I can write this dot x. So that's going to work fine. This concept is called as the initializer list here. So I can write here, and let me try to use that same thing inside the factory constructor. First of all, let me pass some value here. So let's say I pass the value 10. So that's going to work inside this return. So let me do the same thing inside a constructor. Let's say if I write here, let's say this dot x, so it's give me an error because initializer formal parameters cannot be used inside the factory constructor. It means we cannot have this initializer list inside the factory constructor because it is managed using the this keyword, and there is no use means we cannot access this reference inside the factory constructor. Moreover, we cannot use this to call the another constructor. For example, let's say I have some another constructor. Let's say I'll write here abc.demo, which is basically the name constructor here. So inside this name constructor, what I can do, I can write this and I can pass the value 5. So when I'm writing these 5, basically it means it is calling the same class constructor with the one parameter, that is one integer parameter. So this with 5 is basically calling the default constructor. And now let me try to do same thing inside the factory constructor. So let me delete this one from here, and what I'm going to do, I simply want to do say colon, and let me write here this, and let me pass the value 5 here. And you can observe here again I'm getting error because I cannot use this to call the another constructor using the factory constructor. Factory constructor can access the static members of class. It means we can access the static variables and the static methods inside the factory constructor. Right now we have seen that we cannot access instance member, that is the instance data and instance methods inside the factory constructor. But the good news is we can access the static members inside the factory constructor. Let's say we have the variable x here, which is the static, and that's why inside the factory constructor, that is abc.callme, it's possible to use this variable, that is the data member x, because it's a static one. Let me define some method here. Let's say writing your void demo, and basically this demo is a non-static method, that is it's an instance method. So if I try to call this demo here, let's say let me write here demo, you can observe here in line number 14 I'm getting error because instance member cannot be accessed inside the factory constructor. But if I change the same method to let's say static, then it's possible to call such a method because it's the static one. There cannot be factory constructor and the generative constructor with the same name. Inside this class, we have the default constructor with the name called ABC, and what I'm trying to do, I'm trying to create the factory constructor with the same name. So I have written factory and I have the ABC for you. You can observe here, I'm getting error that it says unnamed constructor is already defined. It means we cannot have the same name for the generative and for the factory constructor. Let me try the same thing for this sum name, that is for the name one. Let's say I'm writing like this, and let me delete it, that is I need to return the default constructor. So inside the return statement, that is inside the line number 10, it's possible that it's quite fine. But if I try to write the factory constructor with the name abc.sumName, and I have the generative constructor with the same name called abc.sumName, then we have the error because we cannot have the generative constructor and the factory constructor with the exactly same name. Multiple factory constructors are possible in the class, but make sure that name of each factory constructor has to be different. You can observe here we have the abc.factory1 and we have the abc.factory2. So it's possible that we can have multiple factory constructor as per the requirement. Factory constructor cannot invoke the superclass constructor using the super keyword or using the super construct. You might know that in case of normal constructor, that is in case of the generative constructor, we can call the desired superclass constructor by using the super keyword. But in case of factory constructor, it's not at all possible. Look at this example. Here we have two different classes. We have the class called father, which acts as the superclass. Then we have the class son that extends the father class. That's why it's the subclass for the class called father. Inside the father class, we have two different constructors. The first one is the default one, and the second one is the name constructor that accepts two different parameters of that integer. Then inside the subclass, that is inside the son class, we have the default constructor, then we have the name constructor, then we have the factory constructor called son.demo, which is relying on that is which is depends on the son.sumName constructor. Now inside this default constructor, what I can do, I can simply write, let's say, super, and what will happen if I write super without any parameter, then it simply calls the default constructor, that is the father constructor from the son constructor. Now with the super, let me use super.callMe, and inside this callMe, let me pass 10 and 20. Basically, when we write super.callMe, means it's going to call the father.callMe constructor inside the son constructor. So inside the normal constructor, we can call the super and super.callMe. It's quite possible. But if I try to do the same thing with the factory constructor, so for the factory constructor, let me try to use say super. Then you can observe here will get error because we cannot use super here. So let me describe the error here. It's showing the error. Okay, if you got some time, you can read out this one through my video. Then even if I try to write, let's say super.callMe, then let me change it to say call me. So it's not possible to write that one. So let me write it manually. Let's say call me, and let me pass say some values, say 10 and 20. Even we have the error in the line number 15 itself. Factory constructor cannot be called by subclass constructor using the super keyword. Now don't get confused between the point number 9 and the point number 10. These are the two different points. So in point number 10, what I'm saying that, let's say if we have some factory constructor in a superclass, then such a factory constructor cannot be called by the subclass using the super keyword. Let me explain that one with an example. Here we have two different classes, the father which acts as the superclass, then we have the son class that extends father, that's why it's the subclass. Then inside this son class, that is inside this subclass, we have the normal constructor, that is we have the default constructor son. Now inside the superclass, that is inside the father class, we have the default constructor, then we have the factory constructor called father.callMe. Now inside the son constructor, that is inside the subclass constructor, let's say if I write say super, then it's going to work fine. So when I write super means it's going to call the default constructor, and that's quite fine here. But instead of this, let's see if I try to write super.callMe, then it's giving me an error because we cannot call the factory constructor through the subclass constructor. So it's giving me an error that the generative constructor, that is father.callMe, is expected. So it expected that the callMe must be a generative constructor. It cannot be a factory constructor. So it proves that we cannot call the factory constructor using the super keyword inside the subclass constructor. Let's understand the use of factory constructor. The most common use of factory constructor that I have seen is to implement the factory design pattern, that is to return the subclass instance based on some value or some situation. Basically, it's not a video related to the factory design pattern. That's why I'm explaining the factory pattern a little bit brief. So consider that we have some class and we have the multiple subclasses of that class. And based on the situation or based on particular input, what we want to do, we don't want to return the instance of the class itself. Based on the value or based on the input that we have got, based on that one, what we want to do, we want to return the particular instance of subclass. And it has to be decided inside the constructor of superclass. So based on that one, we want to return the instance of that specific subclass and not the superclass instance. So that type of design pattern is basically called a factory pattern or factory design pattern. Just to create two different input values, we have created the enum called shape type that contains two different values, triangle and rectangle, that helps me to understand two different values for two different objects. Inside this example, we have total three classes. We have the class called shape, which acts as the abstract class, and it is the super class. This shape class is implemented by the class called triangle, and it is again implemented by the class called rectangle. So here the triangle and rectangle acts as the subclasses, and you can observe here we don't have the extend, we have the implement here. So if you don't know what is this extend, implement, and what is inheritance, don't worry, we'll cover all these things in our upcoming videos where I will talk about the concept called inheritance in the Dart. Now you can observe here inside the class shape we have the method called draw. So basically I'm using the draw method simply to print the type or the kind of object. That's the reason you can see inside the class triangle we have implemented void draw method, and I'm printing the triangle so that I can understand that this is what the draw triangle. Then inside the rectangle, again for the draw I'm printing the rectangle. That helps me to identify that it is the draw method of rectangle. For this class called shape, we have the factory constructor, and it is actually the a named constructor here. So inside this constructor, I'm accepting the type of value in the form of the enum. So based on this type, that is based on this value, I'm deciding which object, that is which instance, to return through the constructor. So as it is a factory constructor, I'm bound to return the instance. So first of all, I'm checking if the type is equals to the type of rectangle. So simply I'm returning the object of rectangle, that is I'm returning the object of this rectangle class, that is subclass. And when the condition is false, inside this else part, I am returning the instance of triangle, which is again the instance of this subclass triangle here. So this type of pattern or this type of design is basically called a factory pattern, which is mostly achieved in the Dart by using the factory constructor here. Let's understand how I'm creating the object inside the main. Inside the main, we have written var s1. Basically, this s1 is a reference. So for this reference, I'm calling the factory constructor, let's say shape, and inside this constructor, I'm passing say shape type dot triangle. So based on this triangle value, what will happen? Instead of calling the factory constructor, that is this factory constructor won't initialize the object by itself. So it is initializing the object called triangle by using the factory pattern. Then for the reference s2, again I'm calling the factory constructor shape here. So here I'm passing the value called shape type dot rectangle. So as it is a rectangle kind of value, so this factory constructor will return the instance of rectangle class. And you can observe here, when I will print the s1.draw and s2.draw here, let me run this one. You can observe here, for this s1.draw, I'm getting a triangle because it's the object of the triangle class. And for this s2, I'm getting the value called rectangle, the inside is draw, because this s2 is a reference of a rectangle class. The second most common use of factory constructor that I have seen is to implement the singleton design pattern. Basically, a singleton design pattern is a concept where we create a class, such a class whose only one instance is possible. It means if we try to create the second or third instance of the class, we actually get the old instance. Means anyhow, any case, there can be maximum one instance of that particular class. So such a class is called a singleton class, and that type of pattern is called as the singleton design pattern. We mostly create the singleton pattern in the case where a single object is capable of dealing or it is enough to perform the operations. Or let's say if we have the object which is the heavy in the memory or which is quite complicated to create, and that's the reason it's not preferred to create multiple instances of that class. So in that case also it is preferred to have the singleton class. So if you ask me the best example or let's say practical example in case of Flutter, when we will talk about the concept called SQLite, that is dealing with the SQLite using the Flutter, then to deal with the database, that is to deal with this SQLite, we create the class, and that class has to be a singleton because the single class is enough to interact to perform all the operations. And this is basically a quite heavy class that contains lots of operations, lots of method. So that's the place where we prefer that it has to be singleton, and the factory constructor is the best option for that one to create the single class. Okay, we'll see that later in our example with this SQLite. Basically, let me explain how we can create a singleton class with some simple example here. There are multiple ways to create a singleton class with or without the factory constructor. Even by using the factory constructor, there are several techniques to create a singleton class. I prefer the most simple and easiest way to create the singleton class using the factory constructor. This class taste has got total three things. Let me explain the last one first. Here we have the private constructor called taste._internal. So as we have written underscore, it is the private constructor. Now my intention to make the private constructor is that nobody should call the constructor directly. That's the reason there is no way to call the constructor by itself. So it stops for calling the constructor. That is, nobody can create the object by themselves. Now don't blame me that this constructor means this class and the main is there inside the same library, and anybody can create or anybody can call this internal constructor inside the main. So just imagine that this main and the class, they are there inside a different package or inside the different library. Now the second thing here, we have the static instance. So we have the static and the final instance of the same class, and it is again the private, and the name of this instance is called underscore instance. And why I'm using this static? Because it has to be used inside this factory constructor. And as we have seen in the same video that the instance variable, that is the instance members, cannot be used inside the factory constructor. That's the reason it has to be static here. The reason for final is once it has given the value, nobody should change the value. That's why we have used the final here. And inside this, as it is a final, it has to be initialized here itself. So inside this final variable underscore instance, what I'm doing, I'm calling the private constructor here. So we have the test dot underscore internal here. So what will happen? This particular instance will get an object by using this constructor here. And whenever we call the factory constructor, so it is basically the normal constructor, or it is the named constructor I have chosen here to make this as a factory constructor. Inside this constructor, I'm simply returning the underscore instance, that is, I'm returning this particular instance here. Now you can observe here, as it is the final one, it cannot be changed. So that's why it has the value of this particular constructor. And every time when we call this constructor, that is we call the factory constructor, we will get the same instance through this constructor. Let's observe in the main. We have the test T1 and I'm calling constructor here. Again, we have the test T2 and I'm calling the same constructor, that is I'm calling the factory constructor here. You can observe in line number 18 and 19, I'm printing the hash code of these T1 and T2 just to identify whether they have the same hash code, that is they are the same reference or not. So if I run this program, you can observe here in both this print statement I'm getting the same hash code. So it proves that the T1 and T2, they are not referring to different object. This both the reference T1 and T2, they are referring to the same object, and all the credit goes to the factory constructor, that is the design pattern we have created called singleton design pattern using the factory constructor. The third and great use of factory constructor is to have late initialization of non-nullable members, that is to initialize after the calculation. Let me explain this one with an example. We have the class called reset password that contains two fields, username and the new password. Basically, this reset password class is intended to generate some new password in case of the password loss. So basically, I'm relying on a method called, let's say, generate random password that has some logic, and finally it is returning some password of 8 digits in case of the password lost, which is generating the random password here. The fields called username and new password are the non-nullable field. It means value for those fields is compulsory; it cannot be null. We have the constructor called reset password dot reset that accepts the value of username and the new password. Now, as you can observe here, these username and new password are the non-nullable fields, so it's compulsory for me to accept this one inside this constructor. Let's say if I remove the password from here, then in this case I will get error, so it has to be there. So let me go back to my previous code. And now what's the problem here is, let's say if some user wants to reset the password, so he has a username, means this constructor can accept the username from the user itself, but we cannot ask him to enter some random password because it has to be generated programmatically, and it has to be sent through the mail or by some method, whatever that we prefer here. So practically we cannot call this constructor because the value of this second parameter, that is value of this new password, has to be calculated, and to perform the calculation we have written this method here. So it means we cannot rely on this constructor here. So now it's a problematic for us. To solve this problem, we have a factory constructor. Now we have the constructor called reset password, which is basically a factory constructor. You can observe here, in case of this factory constructor, I'm simply accepting the username. I'm not accepting the password from here. So as it is a factory constructor, I have a chance to do the calculations here. Now you might suggest me that I can remove this parameter from here. I can put body for this constructor, that is the body for this reset constructor. Then I can call this method and I can do all the things. But in case I need to make this variable as the late variable, and I don't want to make this variable late. I want to keep this variable as it is. Even let's say if I make it final, then now you might not have the same question for me that I can do some logic or some calculation here. So if my fields are final, then there is no choice for me. So I need to go with the factory constructor here. So what I'm doing here, the factory constructor is just accepting the username. Of course, it's possible to get it from the user here. Then what I'm doing, I'm calling the method called say generate random password, which is generating some random password for me, and I'm storing the password inside the variable called password. And once I got the password after getting the calculations, I'm simply returning the instance by using this reset password dot reset, which is of course a constructor, and here I'm passing the username and the password. So I hope it's clear for you that how we can make or how we can use this factory constructor smartly to initialize the final fields, or which is actually known as the late initialization of final variable or the non-nullable variable using the factory constructor. The fourth use of factory constructor that I have seen is to return the instance from the cache. Let me explain that one with an example. This example is basically influenced from the example that you can see from the Dart official website. It is very much similar to that one, but having some little difference. So try to observe here. We have a class called person that contains the name of person, and we have the map here, which is basically a static because it has to be called through the factory constructor. Then it is a final because nobody has to modify this one, and it is made private so that it cannot be accessed outside this library. So imagine that this main is outside the library. So basically, at the beginning, this map is going to be empty here. Now we have the private constructor called person.internal that accepts the name because this name is a non-nullable field, so it has to be there inside the initializer list. So as it is a private constructor, nobody can call it directly outside the library. So to do all the things, that is to perform the initialization and all these things, we have the factory constructor, which is of course the unnamed constructor, and that is accepting the name here. Now what I'm doing, I'm not directly relying on this constructor. Before calling the constructor, I'm just doing some logic, or I'm just ensuring that if this basically map, that is the underscore cat user map, if it has the name, so if name is already present, then this particular name or this particular object I'm directly returning. And if such a name is not present, that is if it is not available, then in this case I'm just adding this name inside the map itself, and then I'm returning that object. The method putIfAbsent allows me to add the name inside the map only and only when such a name is not available. So if it is available, the same name is not going to be added inside the map. Instead, the same instance is going to be done. So this factory constructor ensures that only the unique name has to be there inside this particular map. So if I'm getting the repeated name, so such a name won't be added inside this map itself. And just to print the data, we have the method called show data. And to show or to prove that these objects have the same, means these are the same objects with the same name. So I'm simply printing the name, and along with the name, to just have identification, I'm printing the hash code of this name. That is the hash code of this particular object here. You can observe inside the main, we got total 3 objects, let's say person P1, P2, and P3. For P1 and P3, we have the same name called Mark, and for P2, we have the name called John. So let me print the values of these P1, P2, and P3 using the show data. You can observe here, when I run the program for the object P1 and P3, we have the same name Mark, and we have the same hash code because it is the same value. And for the P2, we have the different hash code. Now let me create one more object, let's say P4, and I will try to use same value, say John here. So let me write it here, let's say person P4. So I will use here P4, and let me use the same name John, and let me print the value for this one. So we can write P4 dot, let's say show data, that's fine. And when I rerun the program, you can observe here for the object, let's say P1 and P3, we have the mark and mark here. So we have the same hash code here. But for the P2 and P4, as we have the same name John, we have the same hash code here. And if I try to add some different value here, let me copy someone here, and let me change it, say P5, and let's say I will change this name to say Sam. And let me print the value of this P5, that is the value of Sam here. So we can write here P5.showData. And let me rerun the program. Now you can observe here for the mark and mark, that is for P1 and P3 here, we have the same hash code. But for the Sam, that is for the different value, we have the different hash code. And for the John, for this John, we have the same hash code for P2 and P4. So this proves that using the factory constructor, what is happening here? If the object is available already inside the cache, so it's returning object from the cache. And if object is not available inside the cache, it is returning the new instance, and that is what added to the cache for the later use. That's it for this video. I hope it's clear for you what is factory constructor, its characteristics, and the different use of factory constructor. Still, if you have any doubt or any query regarding factory constructor, feel free to comment me that one so that I can create another video regarding that specific topic that I may be missed in this video. See you guys in the next video where I will talk about the difference between factory constructor and the generative constructor. So don't forget to like, share, subscribe, and hit the bell notification button to get my latest videos.